Welcome to the review for the acid rain test or the acid rain assessment that's going to be taking place soon. And this is just a little extra review for you. So if you're confident, if you've taken good notes, if you've finished all the questions on Schoology, if you've read the readings, you're good with everything, you're studying, you're confident, you'll be fine. But if you still want to do a little extra reviewing, it might not be a bad idea to go through this. And I'm running this off of a notebook file. So here we go. Let's take a look at this first thing right here. So hydrochloric acid. First, when we look at this column, we see some equations or some formulas for hydrochloric acid. Well, not for hydrochloric acid, but for some other acids. So here, if we look at this column, it looks like you have to have the name of the acid. Here, it looks like you have to have the formula for the acid. And here, well, some different facts about each one. So let's take a look at it. Hydrochloric acid. Do you guys remember what acid it is? If you guessed, trying to get this to pop up here, if you guessed hydrochloric acid, you are absolutely right. And where do you find that? You find it in the stomach. Okay, so H2SO4, if you remember, grabbed the wrong one here, is actually sulfuric acid. And sulfuric acid can actually be found in batteries. Did you get that? So pause the video if you need to and try and figure out this one, HNO3. Carbonic, fertilizer, well, some of them aren't acids. If you said nitric acid, you're right. And let's look here, cave formations. We covered that in our weathering unit. So if you're saying it's going to be carbonic acid, and you should know that that's H2CO3, which leaves us with fertilizer. And fertilizers, is going to be your nitric acid. And where do all the acids with an A, the asterisk, in front of them come from? It's going to come from your burning of fossil fuels. So let's take a look at the next slide. And when we look at this stuff right here, I'm just going to scroll down a little bit. A pH of 3 is how many more times more acidic than a pH of 4? Now for this, if you said it is 10 times more acidic, you're absolutely right. Okay, a pH of 3 is how many more times acidic than a pH of 5? Well, if you remember, it's exponential. So if it's the first one is 10, when you go from a 3 to a 4, what's this next one? Well, if you think about it being 10 times 10, what's 10 times 10? If you said 100, you are absolutely right. Now, lime water has a pH of 13.8, making it a strong, what word would fit in there? And I apologize for my writing. I'm trying to write with a mouse here. If you said an acid, making a strong acid, you're absolutely right. Now, a pH scale is numbered from 0 to what? Do you guys remember? 14. Excellent. Normal healthy rain has a pH between what? Do you remember this from our notes? Remember, it's between 5.5. Oops, sorry, kind of wrote that bad. 5.5 and 6. Now, if you flip those around in the test, that's fine. That's fine. So here are some questions for you. Do you know a lot of the definitions? For example, acid rain, snow, sleet are examples of this. Well, look around. And one common thing you can say, they're examples of pH. Well, no, that doesn't make sense. They're examples of carbonic. Well, no, that doesn't make sense. How about salt? Well, no. So you can start to figure out what makes sense, what doesn't make sense. For example, if I look at the next one, a pH of 7, all of a sudden, I know exactly what that is, a pH 7. Oh, yeah, that's neutral. Okay, things with a pH greater than 7, well, if they're greater than 7, that's a base, or would be considered as basic. So let me go down here. Things with a pH of less than 7, I know right away that that is acidic. So when you do a test, do the ones that you know for sure right away. Potential of hydrogen. Oh, pH. Yes. So produce when equal strengths acids and bases are mixed. Okay. Salts. Yeah, that's right. We just had that in a lab that we did. Created when rain mixes with carbonic acid. Or carbon dioxide. Oops, sorry, I gave you the answer there. It's carbonic acid. And then acid molecules attached to soot and dust. Well, it's either dry or wet. Well, these things right here are wet, so this must be your dry. And you'd be absolutely correct with that. So let's move on to the next slide. This is one of those tricky questions. If this comes from the lab that we did. Based on data above, which material reacts with the acid that had a pH of 3? Explain. And a lot of people will come back and they'll say, well, it's granite and steel, right? Well, not actually, because these were exposed to acid rain. They're already in acid and they're staying there. What really reacts is the limestone. So the limestone is what reacts. And the reason why it reacts is because it wants to buffer it. And lime is going to be a base, acid rain's an acid, so they're gonna buffer. Well, the limestone is going to buffer it, and it's going to be more neutral. So this is the one that reacts. So and it's hard in a test sometimes. A lot of people want to say it's granite and steel, but it's actually the limestone. Now another question that will be on a test: which material would be the best building materials in an area with a lot of acid rain? So obviously limestone wouldn't work. Okay. Well, what about granite and steel? Well, do you remember in the lab, what did the steel look like in the beaker? Did you remember the color of the acid? It looked like it was all rusty, and that's true. So you probably wouldn't want to build with steel and limestone. You'd want to build with granite when you're using these three. So let's move on to the next slide. Explain 2 reasons why 93% of the world's acid rain occurs in the northern hemisphere. Okay, so this is one of those questions that's going to be on the test. Well, one, remember, acid rain does what? Acid rain travels. So that's one of the reasons why. And it travels, but why does it travel so much in the northern hemisphere? Why is it located in the northern hemisphere? It travels so much in the northern hemisphere because that's where most of the people live that create the pollution. And so if you have all the people creating the pollution, they're creating fossil fuels, they're burning fossil fuels. So think about people too. What else do they have? They have factories, they have their cars, they have homes creating pollution. So all those are good things that you can write down for this in the test. So when we look at here, you can see most of the people truly do live in the northern hemisphere. Here, true or false? Acid rain is an international problem. That's false, right? No, that's true. And some people might say, well, why is it true? One, there's a couple different ways you can look at it. One, you can say, well, it's true because acid rain happens all over the world. They have problems in the United States, they have problems in France, Germany. It happens all over the world. The other approach, you can say, well, acid rain is an international problem because it crosses borders. If we produce a lot of acid rain here in Wisconsin, or in the United States, it can get up into Canada, or it can go down into Mexico, or if you're in Europe, if you produce acid rain in Germany, it can go into France, or it can go into Poland because it goes across borders. It doesn't get to a border and stop. It's in the atmosphere. It just keeps going. True or false? Acid rain can harm plants. And from our lab, you should also know that that is true. That is definitely true. So let's look at the next slide. Water with a pH level of 4 would create a healthy environment for most plants and animals. Well, water with a pH of 4 would not. So that hopefully you said false. What about this next one? Acid rain is an international problem. Okay, that was also one of the short answer questions. So hopefully whether you do this one first or the other one, you'll come back and say, well, hey, it's the same question, or basically it's the same question. So acid rain is an international problem. True. A body of water is more likely to become acidic if it's an igneous bedrock. Okay, that's false, right? Or is it true? What do you think? Well, think about this. A body of water is more likely to become acidic if it's an igneous bedrock. This would be true because if it was in limestone bedrock, it would actually be buffered and the pH would be higher. But if there is no buffering, it would actually get to be lower. Wisconsin passed one of the first and strongest state acid rain control laws in the nation. If you remember from our notes, it's definitely true. Steel structures are less likely to be affected by acid rain than brass structures. Do you remember this? Do you remember what the beaker looked like in the lab? We've done the lab. This would be true, right? Or would it be false? It's false, because again, if you remember, the beaker was all rusty colored. It was kind of gross when you looked at it. That's because it reacts a lot with the acid. Acid rain can harm plants and animals, and obviously you know that to be true. So let's look at another slide. Explain why people in eastern Canada care about the SOxes and NOxes, sulfur oxides, nitrogen oxides that we put into the air. Again, acid rain travels. And that's what I'm really looking for. Acid rain travels. It doesn't know boundaries. Now on the test, can you fill this out? Label the following pH scale numbers as basic, acidic, or neutral. Again, if you remember, our neutral is 7. Anything higher than that is a base. Anything lower than that is acidic or an acid. Looking at the next slide. Some lakes in northern Wisconsin are very acidic. Explain why the DNR doesn't just mix lime. And we just did this in our lab. Do you guys remember the answer for this? If you said because it produces salt, yes. If you put a strong acid and a base together, what they end up doing is they neutralize each other, but they create two byproducts, are water and salt. And if the lake gets to be too salty, the fish aren't going to survive anyway. And here's a map that shows some of that. And you can slow these slides down and you can take a look at it. But basically, because we have more limestone and dolomite in the southern part of the state, we have less lakes that are sensitive to acid rain. Wisconsin passed one of the first and strongest state acid rain control laws in the nation. In what year? Was it 86? Was it 1800? Or was it 2003? Well, this is one of those where you just take a look at it and what makes sense. It would be 1986. And an ecosystem's ability to resist change in pH is called buffering. Excellent if you got that correct. Soil in which part of the state is fairly good at buffering acid rain? Northern, southern, or none? Okay, for this one, think about what we've been talking about. If you said southern, yes, you are correct. Explain why pure rain has a pH of 5.5 to 6.0 and not a neutral pH of 7.0, like that of distilled water. Again, you could have found this answer in the Schoology questions. You could have found this answer in the readings or the notes. And the answer is what? If you said because pure rain moisture will mix with carbonic acid that's in the atmosphere, you're absolutely right. So pure rain is slightly acidic. It's never a pure 7.0. Excellent job. Typical range for most single roots. This just shows where some plants are very sensitive and they may not grow as well under acidic conditions. And that does complete our quick review. Again, you can slow this video down. You can watch it several times. But between the Schoology questions, look over your notes, make sure you read the readings. And if you go over this, you will be well prepared for the acid rain assessment. Thank you. Again, as always, if you have any questions, just ask in class. Thanks. Bye.